All right, so for our next test, one sample t-test, we're going to use the t-statistic. So we're going to switch from proportions to means. So do me a favor, go ahead and write down your t-statistic here. This should be something that you remember pretty much back from chapter 7. I think the only thing that's a little different here between this statistic is that we use z equals x bar minus mu over sigma divided by the square root of n, but this time we've got to use S of x, right? We have to use S of x because we don't know that sample standard deviation, or that population standard deviation. So we're using our sample one to estimate there. All right, I'm going to go ahead and put all this on the board. I'm going to talk through them very quickly while you guys are jotting these down. The conditions, if you don't want to rewrite all the conditions, that's absolutely fine. As long as you know that these conditions are the same exact conditions for a one sample t interval. And just to remind you what those are, again, you have to have some simple random sample, a random sample, or a random assignment of treatments. And you have to read each problem to figure out what it is being used. I know that coming forward in next chapter, chapter 10, you're going to have a lot of random assignment going on. So if there is a random assignment within an experiment, you cannot say SRS check, and you cannot say random sample check. You actually have to really take a look at that. So that's very important to kind of notice there. Normality, remember there's three different pieces here to normality. If it's given that the population is normal, so the sampling distribution will be as well. If it's not given the population is normal, we look at the sample size and we try to assess if that's greater than or equal to 30. And that's going to be central limit theorem that we're going to use as a result of that, right? Remember, if you name drop, you kind of have to explain what it is you're saying. Does that make sense? I would just say that the sample size is large enough so that the sampling distribution is approximately normal, and then maybe show that inequality where your sample size really is greater than 30. Remember, if it's less than 30, what do you got to do? Graph. And then you have to assess what? What are you looking for? So you're going to graph it and stare at it and just put it on the paper and hope to God you can do it. You're looking for stuff, right? Right? You're looking for outliers, and you're looking for a symmetric shape, correct? An approximately symmetric shape. Slight skew will be okay as long as there's no outliers, okay? But definitely want to make sure that we are kind of assessing that piece to make sure we can move forward with our inference procedure. Remember, sigma's unknown, so we're using S of x to estimate. Remember, that's the whole reason that we use the t-distribution instead of the normal curve. I hope you guys really know that, because when I give you back your tests, there was one question on there about why do we use t versus z, and a lot of you guys got that question wrong. Remember, we're using z versus t because here we do not know the population standard deviation. We don't know the population variance. We don't know anything about this population variance or variation type variable. So we have to use the sample one to estimate. And if we do that, due to that extra variability, we're going to use the t-distributions. In your calculators, I do want you to take a look. Go ahead and play with your calculator. I want you to kind of hit the button so you know what the button is going to be for today. It's going to be number 2 t-test within your calculator. So as soon as you go to stat calc, it's number 2. I'm going to write this up on our inference board. It's number 4. So fourth, it's going to be a one sample test. 4 down, 10 to go. Okay. You guys good? Writing? You guys need more time? Okay. Go ahead and take a couple minutes. All right. Let's go ahead and do our example, shall we? So number 4, it says an insurance company is reviewing its current policy rates. When originally setting the rates, they believed that the average claim amount was $1,800 or $1,800. They're concerned because the true mean is actually higher than this. So they're concerned that the true mean is actually higher, because if that's true, they could potentially lose a lot of money. So what they did a random selection of 40 claims, calculate a sample mean of 1950 with a standard deviation of 500. We're going to carry out a test for significance at the alpha equals 0.10 significance level. So we're doing 10% significance here to see if the company should be concerned. All right. A couple of things that we need to highlight here that are different than the one proportion t-test. Remember, we're looking for words like sample mean and standard deviation. Those are kind of like hints towards what kind of inference procedure you need to use. Okay, so that's why it's going to be a one sample t versus a one proportion z. Does that make sense? All right, so let's go ahead and go through phantoms together. You guys should be good at this now, right? Start off with P. P stands for? And how are you going to state the parameter this time? We want to test the following hypotheses where mu equals the true mean claim amount. And we're going to do this at the alpha equals 0.10 significance level. Now, it does not matter the order in which you state all this as long as it's all there, okay? Because somewhere on your hypothesis test, you have to define the parameter mu, and you have to state your significance level. What I've created here is a statement where if you kind of write all of that, you're going to get all the check boxes. Does that make sense? So that one sentence checks two boxes. It states the parameter and it states the alpha level at which you're testing, right? Hypotheses. What that's going to look like. HO, which is our null. HA, our ha. What's mu going to be equal to? Take a look at your, it's going to be 1800. Very good. Yep. Mu is going to be 1800. And they're concerned because they think it's what? Higher. So we're going to do a greater than alternative hypothesis. Yep. Some of them are easier than others, obviously. That one's pretty explicit. One on your quiz is pretty explicit, right? Yeah. Anybody having confusion about which sign you use there? No, it's going to be pretty, you're going to know. Got some assumptions here. Remember, we're talking about a one sample t-test, correct? So we have three. First being randomness. How do we check for randomness here? We randomly selected claims. Does that make sense? I chose the word selected because I really want you to look at that, but I have up here on the board sample. But I really want you to take a look at what is going on within the context of the problem and respond that, correct? Got to check normality now. How do we check normality? First, is the population normal? Does it say it's normal? Do you guys remember us reading about the population of these are normally distributed? No, we didn't. So, next step, look at what's our sample size? Is that big enough? In order to use what? Which allows us to say that the not population's normal, sampling distribution's normal. Okay. Okay, so since our sample of 40 is greater than or equal to 30, we can assume that the sampling distribution of claim amounts, or X bar, is approximately normal via the central limit theorem. So very important that you know that when we use the central limit theorem, we're not talking about the population, we're talking about sampling distributions. Super important. Super important. And then finally, we are talking about a t distribution because we do not know sigma. It is unknown. So to account for that extra variability within the sampling distribution, we're going to switch from the normal curve to the t distribution. All right, let's continue on. So let's name our test. What's our test for today? One sample t-test. It's going to be fun when we get 14 and then you have to play, okay, what is going on here? So then it implies reading. The first thing I'll tell you to do is I just like to decide, is it a mean or a proportion? Or neither? Sometimes it's going to be neither. Then if it's one sample or two samples, how many samples do that? Those are some key indicators there that are going to help you to narrow down the field of 14. Right. What's our test statistic? Because we have named it as a one sample t-test. Test statistic is not z equals, but t equals. T equals what? X bar minus mu over S of x divided by square root n. Okay, good. Now I gotta pick and put all the pieces in, right? So our pieces as we go from earlier. So we have a sample mean of, if I recall, 1950. Is that correct? We have a true mean of 1800 that we're testing. So that's in our null hypothesis. sample standard deviation of, what was it, 100 something? 500, right? My bad. It's 500. Sample size of 40, correct? So all of that kind of organized there. Just talking you through all the organization pieces there. And then where are we going to kind of go ahead and put this in? T-test, right? So I'm going to come over to my calculator. So clear that out. Stat, we're going to go over to tests, and we're going to go down and do number 2, t-test. Are we inputting data here, or are we inputting statistics that are already summarized for us? So we're going to go over to statistics. Do you guys now see the difference between the two? Okay. So if you type your data in, that's when you're going to use data. If you have summary statistics, you're using stats. All right, so what am I typing in here? View is going to be 1,800. Oops, not 18,000, 1,800. X bar? 1950. S of X? 500. Sample size? 40. What kind of test am I doing here? Greater than, less than? Greater than. So we're going to go over to option 3, correct? Option 3. We're going to do calculate. Bada bing, bada boom. It's done. So we have our test statistic and we have our p-value, right? So next to the formula, let's go ahead and we should write t equals, what was x bar? That was 1950, correct? Minus 1,800 divided by 500 over the square root of 40. And we know that's going to simplify to, remember, I'm not putting any of them on my calculator. I mean, you can, but why not just let the calculator do it for you? Because what are you going to get there? basically 1.90. You can do 897. Doesn't matter, right? So this is still for t, right? For O, what we're going to do, the probability that t is greater than 1.90. And what do I have there as the probability? 0.0326. Is that correct? Right, so we have that. I'm going to go back to the PowerPoint because I already have all that written here. Remember, you could always use TCDF if you wanted to calculate that by hand, but remember, the calculator does that for you when you use option number 2, t-test. Does that make sense? You can find the p-value a couple different ways. I find the t-test button in the calculator much easier, to be honest. So you got this p-value. So the question is, what's p-value? P-value is the evidence against the null. Evidence against null. We're comparing it to our alpha level of 0.10. Do we have enough evidence?
Yes.
Because when the p is low, very good. You guys are getting so good at this. So we're going to reject the hoe. So what are we rejecting here? We're rejecting the claim that it is 1,800, where the mean is 1,800, in favor of the alternative where it is higher than, right? So since our p-value is less than alpha, we reject HO. That means there is convincing evidence to prove. I don't really like the word prove, so I'm going to mark out my PowerPoint. And so this is one of the things that you learn at the AP reading. This is one of those AP reading things that I can give you. When we talk about proving, it's such a strong word to describe what we're doing. We're not actually proving that. We're not doing that strong. We have convincing evidence to suggest. I would say that would be the appropriate replacement word, if that makes sense. Because we would need to do this a little bit more, like more often. We would need to replicate this to really use the word prove. Does that make sense? So I adjusted that. So there is convincing evidence to suggest that the mean claim amount is greater than. I think that's much better. It's safer. Okay. And now you see why I go every summer. These little tidbits, man, they mean a lot. Okay. So what does that mean here? So what's the result here? You read the scenario. They were concerned, which is why we tested the claim. Do they have reason to be concerned?
Yes.
Because they're going to potentially lose a lot of money. So the company's concerns are definitely valid. They are losing a lot of money. Frowny face. Stay sad. All right, example 5. Researcher claims that the average wind speed in a certain city is 8 miles per hour. The average wind speed for a simple random sample of 12 days is below. Do the data provide convincing evidence to support the researcher's claim? Okay. So, poor guy in his umbrella. You guys see that? Trees blowing away in the wind, I guess, right? Seems like a really windy speed, like 8 miles per hour. It's like Wilmington. Wilmington has like a constant breeze. You guys ever go to Wilmington? Literally constant breeze. It sucks in the winter, by the way, because then it's cold and then it's windy. So the wind chill sucks. Right? In the summer, it's nice. Yeah. There's a constant wind chill. Maybe they're talking about Wilmington. All right. Anywho, how many sample data do we have? Less than 30. That's alarming, right? Because that means we might have to graph. We get out of graphing if it told us the population's normal. Anywhere here tell us the population's normal? Looks like we're going to have to do what, kids? Looks like we're going to have to graph this. All right, so brace yourselves as you get to the assumptions because you're going to have to graph. Okay, so let's go through it. We want to test the following hypotheses at alpha equals 0.05 significance level. Notice that they didn't give us 0.05. We just chose 0.05. Remember, that's the most common. We're going to talk about why you want to choose 0.05 versus 0.01 and 0.10 next week when we talk about type 1, type 2 errors that we could make within significance tests. But for today, we are just going to use 0.05, where the true mean wind speed in a certain city is defined as the true mean. Population parameter. So our hypotheses are going to be HO is equal to, or HO colon, mu equals 8. What kind of sign are we going to have for the alternative? Greater than, less than, or not equal to? Because we want to say if it's different from. We don't have a sign, so we're just going to do it not equal to. Now recall, like when we conclude about this hypothesis test, we're only going to be able to say it's not 8. Yeah, and then probably use a follow-up procedure like a confidence interval to see where it really is. Okay? See where it really lies. All right, assumptions here. First one, do we take a simple random sample, or have random assignment in some sort of way, shape, form? What do we have? We have an SRS of 12 wind speeds. Right? SRS here. So that's okay to put SRS if it is an SRS. Again, I will tell you a lot of the things I see on the AP exam. It's like, we randomized this experiment for this, blah, blah, blah. Is there convincing evidence that blah, 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 blah? Kids go, SRS, check. Guys, it's an experiment, not a sample, especially not a simple random sample. No random condition met. You want to know why? Because samples are not experiments. All right, normality. Since our sample data is 12 and that's less than 30, we must do what? Graph. Bird will graph with you. Isn't that nice? I will need someone to read me out scores so I can graph with you. Don't all volunteer at once.
8.2.
8.2. Ooh, I got 2 people doing it. Nice.
7.7.
7.7. Now it's just Karen.
7.9.
7.9.
7.3.
Oops, 7.3.
7.8.
7.8.
7.8.
7.8.
7.1. 8. You didn't put the...
Yeah, I know. I think there was like a mark over here. And that's 37. That's definitely, that would be a really windy day. Okay.
6.8.
I'm bad at typing in today. 6.8?
Mm-hmm.
All right.
7.4,
7.4,
8.5,
8.5,
and 7.6.
7.6. Excellent. All right. You guys know where we're going to look at this? Second y equals. Make sure your stat plot's on. So second y equals. Stat plot on. All right. We need to use which type of graph? I'm going to use a histogram. Let's take a look at the shape, shall we? Graph. Oh, I should hit zoom stat, right? Zoom stat. Kind of looks like that. I mean, does it look skewed in a severe direction? No. All right, let's check for outliers real quick. Do you guys remember which outlier graph we could use? That tells it for us all. Yeah, let's use a box plot real fast. So, looks like a pretty symmetric shape. Let's go check this outlier. So, graph that. Do I have any outliers, or it looks like any outliers? I can zoom in it again just in case. No. Seems to be okay, correct? All right, so remember, what do you need? Rough sketch of the graph. You got to draw a rough sketch of the graph. Label the bottom, all right? Very similar to this. I know I cheated, I already did it. But just a brief graph there, and then maybe some little statement that says, since our data are approximetric, with no outliers, we can assume normality. And finally, our last condition check there is sigma is unknown, so using S sub x to estimate. All right, let's go through. So one sample t-test here. And then we have our test statistic. And since you've already typed into your calculator, we're going to take some time to look at the data button for one sample t-test today. So go ahead and write your name of your test, one sample t-test, and then go ahead and jot down your test statistic. When I'm looking at the formula here, you can write just the formula there, or you can write the formula with the numbers in it, like t equals, and already have the numbers plugged in. Either or is fine. I just need a formula of some sort. All right, switching back over. So we're here, going to stat, going to tests, t-test. Now here, they did not give us the summary statistics. What did they give us? A bunch of data, and we've already typed it in. So we're going to go slide over to data, and we're going to change our mu to be what? 8. And then we are in list 1, which is good. We're doing a not equal to test, correct? And then calculate. And then here is your t-score along with your probability value. So after you have that formula set up, it's going to be t equals, what is it, 7.675 minus 8 over 0.473 divided by the square root of 8, or 12, excuse me. T is going to be equal to, what, negative 2.379. You can do negative 2.38 is also fine. And then P, probability of T being not equal to negative 2.379, it's going to be 0.0365. And that's going to be your probability. Yep, that's the P. The only one that's a little tricky is like the one proportion z-test, because you've got a P sub 0 and a P. P stands for probability. That's why they do a P naught, or P sub 0. All right. How's our evidence looking? What's a p-value? It's evidence against the null, right? So here, if we have evidence against the null, that means we're going to do what? Reject. We're going to reject HO. That means if the true mean wind speed in this certain city is actually 8 miles per hour, there is a 3.65% chance that we would see a score or a wind speed of a mean, I guess we should say a mean wind speed of 7.675 miles per hour or more extreme by random chance. Which means we would not see something that extreme or more extreme very often, only about 3% of the time, which is why we're skeptical here. So in our statement, we're going to say since our p-value is less than alpha, we reject HO. There is convincing evidence to prove, what's that word again? What do we decide to replace it with? Suggest. That the mean wind speed in this city is not 8 miles per hour, right? That's not 8 miles per hour. Which indeed means what? We just proved it's different from 8. How different? It looks like it's lower, right? Which means we can do a quick panic, right? Because we already have all the data in the calculator. We've already checked the assumptions. We've already checked the parameter. The only thing we need to do is a quick one sample t interval, right? You guys with me? A quick one sample t interval? Yeah. So let's go and float back here. Instead of hitting 2, we're going to go stat, test, and where are we hitting? One sample t interval, which is number what? 8. Do we have in our data in the calculator? Yes. Okay. Remember, what confidence level are we going to use here? Generally, this is going to be the complement of our alpha level. Alpha level we chose is 0.05, so confidence level should be 95. 0.95, right? Calculate. All right, so here is your 95% confidence interval. You guys with me there?
Yeah.
Are you shocked that it's 8 is not in that interval? No, because we rejected HO. If you reject, that number that you're looking at is not going to be within your interval. Our sample mean was lower than that, so it makes sense that our whole interval is actually below that, right? Does that make sense? Okay. So that is what we did here. So we just did a quick one sample t interval. Here's x bar plus or minus t star times s of x over square root n. I'll save you guys the trouble of trying to locate z star on your own, because again, this is a very quick and formal one, but that t star is indeed 2.20. So what we're able to say with confidence here is that we are 95% confident that the interval from 7.37 to 7.98 miles per hour captures the true mean wind speed in this certain city. And all of that falls below that suggested mean of 8. All right, homework over the weekend. Watch Edpuzzle. You're going to be watching the match pairs t-test Edpuzzle video. And we will come in on Monday and we'll practice both one sample t-test and match pairs t-test, and we'll talk about similarities and differences between the two. You guys good with that? Okay, so please, please, please use this weekend to do a nice job of really understanding what a match pairs t-test is. I'm not giving you any other assignment, so I'm expecting quality here. I need some quality notes. Quality, when I ask you questions on Monday about a match pairs t-test, I want to be like, oh, cool, they actually watched it. They understand what's going on. Yay, let's do this fun thing. Versus, here, let me reteach it all, right? That would suck. All right. Cool. And that wraps up today.